Hello again. Last section of chapter 6, average value of a function. Let's review a few concepts here to make sure we know the difference. One concept from algebra is the average rate of change. Of a function between points with x1 and x2. So the average G here. Well, the f average in this case is f of x2 minus f of x1 divided by x2 minus x1. It's the slope of the line passing through those points. So this is the average rate of change of a function between 2 points. Number 2, second concept, rate of change. Not the average rate of change, the rate of change of f of x is f prime of x. So the rate of change is f prime, the derivative. The average rate of change is a number between 2 points. And number 3 is the average value of a function. So for continuous functions, the f average on an interval a comma b is 1 over b minus a, the integral, the definite integral from a to b, from f of x dx. Please understand these 3 concepts, totally different. So this is for continuous functions, so we can apply the fundamental theorem of calculus part 2 from chapter 5. Okay, one other concept before we look at the problems and examples here is the MVT, mean value theorem for integrals. Of course, f of x continuous. So there must be a value c in the open interval a comma b such that f of c equals f average, which is 1 over b minus a, the integral from a to b from f of x dx. If we cross multiply, in other words, this means that f of a particular number in that interval multiplied by b minus a must equal the integral from a to b from f of x dx. What does this mean? It means that in a particular, let me illustrate for a positive function. Let me illustrate what this means for a positive function. So let's suppose, let me use a different color for the function. Now let's suppose we have this function, let's say between a and b. The area under this function is exactly this, the integral from a to b from f of x dx. That's the area under the graph. And we must find a point or an x value somewhere, c, such that this rectangle with a height at f of c, this rectangle will have the exact same area with the area under the graph. That's the mean value theorem for integrals. And this is an illustration for a positive function. Of course, f of x continuous on a comma b. Every time we calculate definite integrals, we should always check that the function is continuous on the given interval. And let's illustrate with a few examples here. Let's start with, which page am I on? I'm on page 475, so let's start with 475. and we are given a function g of t, which is 9 over 1 plus t squared. The interval is 0, 2, so obviously this function is defined everywhere, so there is no problem. We're asked to find g average on the open interval 0, on the closed interval 0, 2. So it's 1 over 2 minus 0. The integral from 0 to 2 from 9 over 1 plus t squared dt. Of course, a 9 will go out, 9 halves. Which function prime is 1 over 1 plus t squared is the arc tangent t from 0 to 2. When I plug in 2, I don't have an answer because I don't know the angle whose tangent is 2. But when I plug in 0, I get 0 because I know tangent 0 is 0. So this is the final answer. Let's also look at 7 on 475. And we are given h of x. And this is cosine to the fourth times sine x. And the given interval is 0 pi. Of course, the same question. Simply find, in all these situations, we're asked to find the average value of a function, f average, on the given interval. Okay, so h average on the interval 0 pi is 1 over pi minus 0, the integral from 0 to pi, from cosine to the fourth sine x dx. Definitely, I will use a substitution here. And I will say, let u be cosine x. Let's see du, that is negative sine x dx. I do have sine x and dx in the problem. I don't have the minus. Who cares? I can multiply by -1 twice. And at this point, I will have the negative with sine x and dx. Negative sine x and dx will change into du, and cosine to the fourth will change into u to the fourth. I will still have outside a -1 over pi. Please do not copy the limits of integration. They cannot be the same. So careful, please. So then the next step, that's page 3. We'll have -1 over pi. We do have u to the fourth. We have du. When the limit of the lower limit for x is 0, cosine 0 is 1. When the upper limit for x is pi, cosine pi is -1. So therefore, -1 over pi, u to the fifth over 5, from 1 to -1. -1 over 5 pi outside. I plug in -1, and I get -1 to the fifth is still -1, minus when I plug in 1, so I have -2 with minus in front, 2 over 5 pi. This is the average value of this function on the given interval, 0 to pi. Okay, let's look at one more here, number 9, on the same page, 475. And we have f of t equals 1 over t squared, and the interval is 1, 3. Again, here, I did not say whether the function is continuous because cosine and sine are continuous everywhere. But we should always check if this function is continuous on the given interval. Here, we're asked to do a few things. One question is find the average value, then find C, and then present a sketch of the graph. So we have part A, find the average. That's nice. So f of t average between 1 and 3 is 1 over 3 minus 1, which is 2. The integral from 1 to 3 from 1 over t squared dt. So a note, a separate note, side note here, please, this is super important. Please remember that 1 over t prime is -1 over t squared. When we integrate 1 over t squared dt, we'll get -1 over t plus a constant c. Super important from Calc 1. So therefore, I know that this is negative 1 over 2 and 1 over t, of course, from 1 to 3. And this is negative 1/2. When I plug in 3, I have 1/3, minus when I plug in 1. So I have negative 1/2, and this is negative 2 over 3. And the answer is 1/3. So this is the first part. In part B, they're asking us to find that c such that f of c times b minus a is the integral from a to b from f of x dx. Okay, so this is what we had a minute or 2 minutes ago. They're asking us to find c in the interval 1, 3, 1, 3. Find c such that this is fulfilled. Okay, so that's my page 4. Okay, so basically, since I already have all that calculation done, so f of c equals 1/3. Okay, so what is f of c? Look at the function. The function given to us is 1 over t squared. So 1 over t squared equals 1 over 3. So then t squared equals 3. Okay. That was, I'm just checking my calculations for a moment. That was 1/3. So then f of c equals that. Yes, okay. So then t equals plus or minus the square root of 3. And since we know the interval is 1, 3, we are only going to use c as being the square root of 3, which is approximately 1.73. Okay, so now part C, last part of this problem, we have to illustrate with a graph. No problem. Remember we have, no, it was f of t. F of t equals 1 over t squared, okay? So that's my t. It's not g. The previous problem, I think, had g in it. G will go away. Good. So I know how to graph 1 over t. Remember, 1 over t is this graph. This is 1 over t. Famous graph, we should always remember it. Well, 1 over t squared, all those numbers are a little bit bigger because t and t squared, right? So from 0 to infinity. So the shape is identical. No question there. So 1, 2, 3. This is between 1 and 3. This is the area under the graph. And our square root of 3 is at 1.73, somewhere here. Here's the height of f of c. And this area, the area of this rectangle with c and f of c has the same, this rectangle has the same area with the area under the graph. Thank you. I hope this helps you discover this section even further.